Can you see me drawing on the live board? Can you see me? Alright. Okay, for perpendicular bisector theorem, let's say this is point A, B, C, and then you have B here. Alright. In a plane, if a point lies on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So if CP, line CP, is the perpendicular bisector of segment AB or side AB, then CA is equal to CB. So that means this side here is equal to this side. Okay, so that one is for the perpendicular bisector theorem. And then for the converse of the perpendicular theorem, perpendicular bisector theorem, converse of that. Okay, let's say this is point C. Alright, and this is point A, B, and D. It's indicated that this one is congruent to that or equal, and this one is congruent to that. So if in a plane, if a point is equidistant from the endpoints of a segment, then it lies on the perpendicular bisector of the segment. So if DA, where's DA? DA, this one, is equal to DB, then point D lies on the perpendicular bisector of side AB or segment AB. Okay, so the first one is the perpendicular bisector theorem. The second one is the converse of the perpendicular bisector theorem. Okay, any questions on that? I'll delete. Is it the same as your lecture? Yeah, it's the same there. Okay, can you, okay, I will delete this. Okay, and then we have angle bisector theorem. Angle bisector theorem. So we just have to, okay, let's say we have this one. Okay, let's say this is point A, B, C, D, and then, okay, and this is right angle there. Okay, so if a point lies on the bisector of an angle, then it is equidistant from the two sides of the angle. So this is the angle bisector theorem. So if line AD bisects angle BAC, so this is BAC, and side DB is perpendicular to side to ray AB, and DC is perpendicular to ray AC, then AD, DB, DB is congruent to DC. Where's DB? Oh, this one. Okay, so if line AD bisects angle BAC and DB is perpendicular to AB and DC is perpendicular to AC, then DB is congruent to DC. Okay, so that one is the angle bisector theorem, and the converse of that, converse is if DB is perpendicular to ray AB, and DC is perpendicular to ray AC, and DB is equal to DC, then AD bisects angle BAC. So the converse is basically the opposite of the previous theorem. And now let's solve the problems you have here. Can you see that? It's too small. Okay, find the indicated, okay, yeah, we find the indicated measure, explain your reasoning. All right, so we need to find the measure of AB. Okay, so AB, well, this is AB, right? And then AC is equal to 9, BD is equal to 6, as well as that one. So what would be our, what's this? This is angle bisector, a perpendicular bisector. So that means AB is also equal to 9. Is it? Yeah. Because it is indicated that BD is congruent to DC. And then the same thing with E, the second figure. Okay. EH is congruent to GH, right? So this is also 3. Therefore, EG is equal to 6. Yeah? That one is also a perpendicular bisector. Then SU. Okay, so this is SU equals TU, right? So we just have to equate, solve for X and solve for SU. Okay, we solve. There is 2x plus 2 equals 3x. Then we group like terms. Minus 2 minus 3x minus 2. That one. So we have 2x minus 3x. This is negative x equals negative 2. So x is equal to 2. Therefore, SU, which is 2x plus 2, is just 2 times 2 plus 2. This is 6. So SU is 6. Right. Find the equation of the perpendicular bisector of AB. So we find the equation of the perpendicular bisector of AB. So let's assume this one is the perpendicular bisector. Let's say this is line L. So to calculate or to find the equation of this perpendicular line or perpendicular bisector of AB, we need to find the slope of AB first. Alright? Still remember the slope formula? So we're given here 2 points. So point A is 0, negative 2. That is negative 2, right? And point B is 2, 2. So we need to find the slope of this. So slope of line AB is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So let's say this is x sub 1, y sub 1, x sub 2, y sub 2. So this is 2 minus negative 2 over 2 minus 0. So the slope of AB, line AB is just 2 plus 2, 4 over 2, which is equal to 2. Okay, now we need to find the slope of the perpendicular bisector, which is line L. So line L, the slope of line L, since it is perpendicular, so it is just the negative reciprocal of the slope of line AB. So this is negative 1/2. So that is the slope of line L. Therefore, the equation of line L is just y equals negative 1/2 x plus b. So what is the y-intercept here? To find the y-intercept b, you need to find, are you still there? You can choose any of the points. Let's say we choose 0, negative 2. So we plug into this equation. So this is negative 2 equals negative 1/2 times 0 plus b. So b is equal to negative 2. Therefore, the equation of the perpendicular bisector is just y equals negative 1/2 x minus 2. That one. Okay, you got that? Yeah, no questions on this? Alright, it's too small. Okay, find the indicated measure. Explain your reasoning. So I'm zooming it in, but you won't see it in your end. Okay, number 5. The measure of CAB. So what is this? Angle bisector. Yeah. So angle bisector, this is the converse of angle bisector, because we're given here that DC is perpendicular to AC and DB is perpendicular to AB, and DC is congruent to or equal to DB. So that means AD bisects angle AC. So angle CAD is equal to angle BAD, which is equal to 20 degrees. Therefore, the measure of angle CAB is 40 degrees. Right. Oh, you thought it was asking for this? CAD? It says CAB. Oh. Okay, next one. Next one is the same. Oh no, this one is angle bisector, because we're given here angle bisector theorem. So we're given here angle BAD and CAD equal. So that means BD is equal to DC. So DC is also 5, equal to 5. So if AD bisects angle BAC and DB is perpendicular to AB and DC is perpendicular to AC, that means BD is equal to DC. And then the next one is, okay, this one is angle bisector theorem. We can apply angle bisector theorem here. BD. So we find BD. So we're given here that these two angles are congruent. So that means BD is equal to DC. But BD is equal to 3x plus 1 and DC is equal to 5x minus 1. We need to solve for x first. So we subtract 5x and 1 from both sides. Yeah, 5x minus 1. So this cancels out. So we have 3x minus 5x equals, this also cancels out, negative 1 minus 1. So this is negative 2x equals negative 2. Divide by negative 2. So x is equal to 1. Therefore, BD here is equal to 3x plus 1. This is just equal to 3 times 1 plus 1, or 4. So BD is equal to 4. Right. Alright, so BD is equal to 4. Okay. Then we go to the next problem. Where is that? This one. Okay. Number 8, number 9, number 10. Okay, find the indicated measure. So this one is perpendicular bisector. Yeah. Okay. So we're given here that this side, no, this side is congruent to this side. And this one is 60, 90, 30. Okay. So that means this side is also congruent to this side. Converse, if we're going to calculate this angle, this is 90 degrees. So that means this is perpendicular bisector theorem. Okay, then we can just equate them. AC is equal to, no, AC is equal to AB plus BC. But we need to solve for x first. AB is equal to BC. So we just equate. AB is negative x plus 25 equals 3 times 2x minus 8. Then this is negative x plus 25. We distribute 3. So 6x minus 24. Then we subtract 6x and 25 from both sides. So this cancels out, this cancels out. Then we have negative x minus 6x equals negative 24 minus 25. So this is negative 7x, negative 49, divide negative 7. So x is equal to 7. And now we can calculate for AB. AB is negative 7 plus 25. What is that? And then BC is 3 times 2 times 7 minus 8. So 14 minus 8 is 6. 6 times 3, so this is 18. Yeah? And this is also 18. Therefore, AC is just equal to 18 plus 18. So AC is equal to 36. Right? Did you get that? Okay. Let's go to number 9. What is the measure of angle L and M? So where is, this one. This one is L and M. And we're given that angle NLM, angle NLM is equal to 90 degrees. Alright, this is bisector. So perpendicular bisector, that is 90 degrees. So that means this side here is equal to this side. KL is equal to LM. So that means MN is equal to KN. Right. But we are asked for angle L and M. This one is the 5 halves, right? And that one is 5, 0. So we need to find the distance LM. Okay. So we use the distance formula. Distance formula is the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So let's say this is x sub 1, y sub 1, x sub 2, y sub 2. So LM is equal to the square root of x sub 2 is 5 minus 5 halves squared plus 0 minus 5 halves squared. Let's just solve the distance, okay? So the distance from point L to M, that is, okay, LM, that is 5 minus 5 halves. So 2 divided by 1 is 2, so 10 minus 5 is 5. So that is 5 halves squared plus negative 5 halves squared. So this is square root of 25 over 4 plus 25 over 4, or the square root of 50 over 4. Are we on the right track? 5 minus 5 halves is 5 minus 5 halves 5 over 2. No, 5 minus 5 halves. So 5 over 2 is 2.5. So 5 minus 2.5 is 2.5, so 5 halves. Okay, so this is just 5. This 25 times 2 is 50. Square root of 2 over 2. So that is the distance from L to M. And then we find the distance from N to M. So MN, if that is 5, 0, then N is 0, 0. Right. So the distance between M and N, so that is x sub 2 minus x sub 1. So that is 5 squared plus 0. So this is only 5. So that means the length of here is 5. Now we can solve for the angle. Oh no, using law of cosine. Because I can solve this using law of cosines. Because we have side, see, we have this side and then this included angle. Once we solve this angle, then we will know angle L and M, because we will just subtract from 180. We're already given this one, the right angle. You can solve this using law of cosines or vectors, but of course you're not there. You're not there yet. Yeah, this angle should be equal to this angle. Now we've already solved the distance between them. This is 5 square root of 2 over 2, and the other one is 5. I'm just assuming this angle is congruent to that one. So that's, I will go over that later. I will check. Let's move to number 10. Okay. So for number 10, okay, so we're given here that, okay, VW bisects TW. That's why it forms a, no, it's perpendicular to, or bisects TW, that's why we have it forms a right angle there, as well as VU and TU. So that means this angle here is congruent to this angle, right? Angle UTV, and angle VTW. And we are asked for the measure of angle UTW. So angle UTW is just equal to the measure of angle UTV plus the measure of angle VTW. Okay. So which is 2x plus 3 plus 5x minus 24. Okay, but these two are congruent, so we can just equate them. 2x plus 3 equals 5x minus 24. Well, we solve for x first, so we subtract 5x and 3 from both sides. So this cancels out, and this one. So we have negative 2x minus 5x equals negative 24 minus 3. So this is negative 7x equals negative 27. Yeah? No, 2x minus, okay, my bad. 2x minus 5x is negative 3x. So negative 3, then x is equal to 9. And now we can solve for, we plug in the value of x here, which is 9. So this is 2 times 9 plus 3. And this is 5 times 9 minus 24. Okay, can you solve for that? 2 times 9 plus 3. 21. So this is 21. And then the other one is 45 minus 24. 21. 21. Okay, so that means this angle here is 21 degrees. Therefore, angle UTW is equal to 42 degrees. Yeah? Because they are, it's indicated that they are equidistant. This one, UV and VW. And then it bisects. Okay. We move on to the next problem. I'll just go over this, okay? And we'll check that. Can you please clear the board? AC is perpendicular bisector to BD. Find AD. So perpendicular bisector. You just have to check the theorem for perpendicular bisector. So if CP, if AC is the perpendicular bisector of BD, then that means AB is equal to AD, right? So this is right angle, right? So we're given BC, this leg and this leg, we need to solve for AB. So AB using Pythagorean theorem, so AB squared is equal to AC squared plus BC squared. So AB is just equal to the square root of AC squared. AC is 4, so 4 squared, and BC is 3, so 3 squared. So this is the square root of 16 plus 9, which is 25. Therefore, AB is equal to 25. Did you get the same answer? 25. Alright, and 5 because this is square root of 25. Sorry, it's 5. and AB is equal to AD, so that is 5. Okay, number 12, AC is the perpendicular bisector of BD, and then we find AC, this one, X, which is X. So that means AB is equal to AD, so that means this is also 10. So that is AB squared using Pythagorean theorem equals X squared plus BC squared. BC is also 6. So X squared is equal to AB squared minus BC squared. So X is equal to the square root of AB squared is 10. 10 squared minus BC 6 squared. So X is just the square root of 100 minus 36. So what is 100 minus 36? Is it 64? Square root. So yes. So that means X is equal to 8, or AC is equal to 8. Yeah, I think we've solved everything.